this example, I'll show you how to find the x-intercepts and to test the symmetry of this equation. Solution. First, we're going to find the x-intercept. To find the x-intercept, we let y equal to 0 and solve for x. So now I'm going to this equation here, replace y by 0. And we solve for x. Now when I replace y by 0, this 0 here I can put the 0 over 1 because 0 over 1 is 0. So this equation here I can rewrite nice and neat. It look like 0 over 1, which is 0, and we replace that by y. Here's my equation. This reminds us that if we have a over b equal to c over d, this is called proportion. So, and when we have a fraction equal to another fraction, we call this a proportion. We can use the cross product, meaning I take a times d equal to c times b. So in other words, when we have two fractions equal to each other, I can rewrite as a times d equal to b times c. So we can solve for equations. It's easy to solve equation this way. So now I take 0 times this bottom here is 0. And then this top here times 1 itself. Now to solve for x is easy. You can either factor out or you can just using the square root method. By plus 9 both sides. I have x squared equal to 9, take a square root. A real number, take a square root, I have plus or minus 3. Because this, when you factor this one out, you will have x minus 3 times x plus 3, and you solve for x and have the same answer. So your x-intercept is 3, 0 and minus 3, 0. That is our two x-intercepts. To find y-intercept, we let x equal to 0 and we solve for y. So we go back to our equation here and replace x is equal to 0 here and over here. So I have y equal to 0 squared minus 9 and 0 squared plus 2, which is minus 9 over 2. So that is our y-intercept, is the point when x equal to 0, y is minus 9 over 2. Now to test whether this equation here have x or y symmetric or the origin, here's how we do. Let me copy the equation again. Now to test if this equation here have the x symmetry or not, we have to replace y by minus y. So every time we see y, we replace by minus y, which is minus y equal to x squared minus 9 over x squared plus 2. Then I'm going to simplify this equation by multiply the whole thing by minus 1. So minus 1 times y. Minus y is positive y. Minus 1 times this guy. But this is a whole number. This way he's a whole one number. So I put a minus and then x squared minus 9 over x squared plus 2. Okay, remember this is some number in fraction. So remember if you have a minus 1 over 2, it's the same thing as a minus 1 then over 2 or we can rewrite as 1 over minus 2. It's the same thing. This just the minus sign here. This rotates. It's move. Okay, so remember this is a one nasty fraction. You multiply by minus 1. So for example, if you have 1/2, you times by minus 1 is a minus 1/2. And there's 3 ways to write this. So I choose to put the minus in the middle. And then you ask yourself, is this result here look exactly what I had before, the given equation? The answer is no. This is a positive fraction, and this is because you have minus here, that makes this fraction here is a negative. So therefore, the result is not the same as the original equation. So therefore, the answer is no, meaning this equation that giving to us is this equation has no x symmetrics. So the test y symmetric. For y-axis symmetrics, we have to replace x by minus x to the original equation right here, and then we compare our result. So every time we see the x, we replace by minus x. So I have x squared, I replace by minus x, and then square minus 9 over minus x squared plus 2. Then we simplify. We have this meaning minus x times minus x, which is x squared, the positive, minus 9. Then this also meaning minus x times minus x, which is x squared, and plus 2. This is our result after we replace x by minus x. And then we ask ourselves, is this result here look exactly the same as the original, which is this one? And the answer is yes. The answer is yes. So therefore, that means this equation here has the y-axis symmetric. Yes. Now let's test the origin and see this equation have the origin symmetric or not. And to do this you have to replace y by minus y, and then x by minus x at the same time. So here's our columns here that I copy it down. Replace that. Every time you see the y, replace by minus y. Every time you see the x, replace by minus x. Then we simplify. For this case here, I have x squared minus 9 over x squared plus 2. Then I simplify my equation a little bit more by multiply the whole thing by minus 1. So I have y equal to minus, and then x squared minus 9 over x squared plus 2. And then ask ourselves, is our results look exactly as our given equation? The answer is no. That means this equation here has no origin symmetry.